Good morning, everyone. Over the last several decades, optimization has fundamentally changed how forest planning is done. It has allowed us to move from intuition-based planning to structured decision-making across very complex landscapes. Today, optimization models help organizations balance timber production, ecosystem objectives, long-term sustainability, operational constraints, and economic goals, often across thousands of hectares or acres, and planning horizons of weeks, months, years, or decades. These advances have dramatically expanded what planners are able to represent and analyze within a single model. But as these systems have become more capable, the nature of planning challenge has also started to evolve. And that shift raises an interesting question for our field and for my job. What should the next generation of planning optimization software help planners do better? This is what we're going to look at today. To explore that, we're going to cover three things this morning. First, where planning optimization may be heading, and how those challenges in planning are evolving as our models become more powerful. Second, I'll show you what we're building to support that shift, the Woodstock platform, foundation, and a look at next gen. And finally, I want to talk about how we're going to get there together, how this transition can happen in a way that builds on on the work that many of you have already done. And as I've said, we're going to have a much longer periods of questions at the end. So, first topic. One of the most remarkable things about forest planning over the past several decades is how powerful optimization models have become. In this conference, I think you have had already multiple examples of this. Today, we can represent extremely complex systems within a single model. And that level of analytical capability has fundamentally changed how planning decisions are made. So instead of evaluating only a handful of scenarios manually, optimization allows planners to explore an enormous decision space. It identifies solutions that balance multiple competing objectives in ways that would be almost impossible to discover otherwise. Optimization has become a very powerful decision support tool available in forest resource management. But as models have become more powerful, something else has grown alongside that capability: their complexity. If you look at an optimization, if you look at an optimized section of the early 2000s, it might have been a few dozens line long. However, today, it's not unusual to see an optimized section with hundreds or thousands of lines. And they describe policies, constraints, objectives, operational rules. And the more factors they represent, the more interaction emerges between different parts of the model. And that complexity is not a flaw. It is actually a reflection of the real systems that we are trying to represent. Forest landscapes are complex. Supply chains are complex. Management objectives are complex. But this also means that optimization models can sometimes become difficult to understand, to interpret, and to explain, even for experienced modelers. So as models grow larger and more sophisticated, understanding why a particular result emerges can require significant effort. And because of that complexity, building and refining an optimization model is typically an iterative process. Modelers rarely get everything perfect on the first run. Or if you do, you should really question something. Instead, the process usually looks something like this. We build or update the model, we do some syntax check, we run the optimization, we examine the results, the harvest levels, the spatial allocations, the constraint behaviors, the objective values, and then we try to interpret what the model is telling us. Often, that interpretation raises new questions. Maybe a constraint is limiting the solution more than we expected. Maybe an action was scheduled less than we anticipated. Maybe a development type is behaving in a way that is surprising. Maybe there is an input data error. So then We adjust assumptions, we refine the model, and we run the optimization again. That cycle, build, run, interpret, adjust, is very natural for a modeling complex system. But it is important to emphasize that this iterative process is not a weakness of optimization. In fact, it's one of the strengths of optimization modeling. Because optimization models are not just tools for producing one answer, they are tools to learn about a system. So through iteration, planners explore how different constraints interact, how different objectives compete, and how different assumptions influence outcomes. In many cases, the most valuable insight does not come from the final scenario alone, but from what you've learned through that process, that exploration process. So, iteration is not something we want to eliminate. Also, over the past several decades, an enormous amount of R&D has been focused on improving the computational side of optimization. The solvers have become faster. The algorithms have become more sophisticated. Hardware has become dramatically more powerful. As a result, today's optimization engines can solve models that would have been unimaginable 20 or 30 years ago. And these tools are extremely effective at running models and generating solutions. But understanding the system behind those solutions still requires significant effort from the planners. So in many cases, they need to read files, they need to analyze reports, they need to mentally piece together how the model behaves. So while we've made tremendous progress on the computational side, the next step is to better support how planners understand and reason about their models. In many ways, the computational power is no longer the main bottleneck for most. The opportunity now is to help planners better understand the models they build. And so we think about this as two generations. The first generation focused on building powerful optimization engines. And before talking about what comes next, it's important to acknowledge the foundation that we stand on. Woodstock itself exists because of the extraordinary work of its original developer, Hugo Funicus, whose ideas have shaped how many of us think about the forest planning models today. And at the core, these tools were designed to run models, compute solutions, and generate reports, and they did that extremely well. But as planning systems become more complex, a new need emerged. Planners increasingly need tools to help them understand the system behind the solution. So that's the shift here. The next generation of planning software builds on powerful optimization engines and add a new layer. Tools that help planners see the structure, better understand decisions, not just run models. So the next step, or the next leap in planning software, is about helping that understanding. But what does it look like in practice? In our work with the next generation of planning optimization tools, we've been thinking about this in terms of three main capabilities. One is structural visibility, helping planners see the structure of their model and how different components interact. Second, decision transparency, helping planners understand why solutions behave the way they do. And third, exploration, making it easier to test ideas, experiment with scenarios, and learn how system responds. So together, these three elements, they form the foundation of what we believe next generation of planning software should support. Let's talk about the first capability, structural visibility. So we know that planning models, they have many interacting elements. They have actions, operability to rules, constraints, transition, time, allocations. And traditionally, these relationships are spread across many files, tables, or reports. So understanding how the system is structured often requires planners to mentally reconstruct it. So structural visibility makes that structure visible. So instead of piecing things together, the planners can see how decisions connect, how the rules are interacting, and how the model is organized. This makes it much easier to reason about the system you are working with. You can finally see how the system is organized. The second capability is decision transparency. So optimization models can produce very sophisticated solutions, but the reasoning behind those solutions is often difficult to see. And when something unexpected appears in the result, planners often have to dig through reports and constraints and inputs to understand what is shaping that outcome. So that decision transparency helps make those influences visible. With this, you can identify what is driving the decision, which constraints are active, and where the system is being limited. So that helps with diagnosing issues, explaining results, and building more confidence in how the model is behaving. Lastly, we want to easily explore scenarios and trade-offs. So that capability is for exploration. Planning is not just producing one solution. It's about understanding the range of possible outcomes and the trade-offs between different decisions. And today, exploring those questions can require building new scenarios, modifying some inputs, running them all again, analyzing reports. Exploration tools make that process easier and more interactive. They allow planners to test ideas, compare scenarios, observe how the system responds to different assumptions. Instead of only generating answers, the system becomes a tool for learning about the landscape and the decisions that shapes it. Optimization becomes a conversation with the model. And so where we had today, the cycle of model, run, report, interpret, what we're proposing is an upgrade of that. And to go with model, explore, understand, solve, and explain. And when those capabilities come together, we think that it could, just enhance the workflow of planning itself. So that's why we think that right now, the real challenge is not about solving bigger problems. The challenge is more about helping planners understanding the system they're managing. Up to this point, I've been talking about where planning optimization is heading. So at this point, we would like to perhaps see what it means in practice. What kind of tools and capabilities would allow planners to see structure more clearly, understand decisions easily, and explore the system more effectively? And this is what the direction that we've been going towards with the Woodstock platform. So in the next step of the presentation, I would like to show you two things. The platform foundation that makes this possible, and second, a look at Woodstock Next Gen, where you can see those ideas that are starting to be shaped. For those who didn't know, over the last few years, we've been rebuilding Woodstock as a platform this time. And what this means is that instead of thinking about Woodstock as a single application, we think of it as a shared optimization core. And the core contains the fundamental pieces of optimization modeling. It has the data structures that represent landscapes and resources. It has the engines that generate and solve models. And it has the capabilities to support planning workflows. And because those pieces are shared, the same foundation can now support multiple kinds of applications. For example, if you have a common optimization platform, something interesting starts to happen. We can use that same foundation to support, for example, we have Woodstock Next Generation, which is the modern desktop modeling environment. You can also use that foundation to embed point optimization directly inside operational workflows. What this means is that you could have optimization right where decisions are happening in other products, and for example, in other Remsoft products. We could also have the same platform support optimization services through APIs, enabling cloud-based workflows and integrate into other systems. And so once we have this foundation, the Woodstock Platform Foundation, it opens doors to entirely new kinds of optimization application, even some that we certainly have not yet imagined. And the Woodstock platform is not just a single tool. It's a foundation for an ecosystem of optimization capabilities. And today we're going to focus on one specific Woodstock Next Generation. In this part of the presentation, I would like to show you some of the components And so at this point, I'm not going to show you a full product demonstration, a full feature demonstration. I'm going to show you 3 moments of Woodstock Next Gen, 3 small examples of how the experience is already starting to change, to give you a sense of direction. The first moment is going to be a moment of clarity. So how quickly can you understand your model? The second is a moment of simplicity. We're trying to remove friction from modeling tasks. And finally, a moment of continuity, connecting planning to operations across other systems. So for the first one of the design goals of Woodstock Next Gen is very simple. When you open the model, you should not feel lost. You should be able to understand what you're looking at almost immediately. You can see the model, you can see the scenario you're working on, and you can see its current state. You can see how the system has performed. So instead of starting with a file structure page, you can start to have a clear view of the system. You know where you are, you know what you're working on, and you know what the model was doing. So you have that feeling of, I get it, I'm ready to work. The second is about simplicity. In many cases, making a change in the model means that you have to figure out, how you're going to express what you want to model and where to apply it. And this could take time. So instead here, you have an example of a feature where you can describe what you're trying to do. And the system will help you think through it. It will give you suggestions, ideas, and possible approaches, but you stay in control of the model. This feature here is not about automating modeling, it's about making it easier to move from intent to implementation. The goal here is to simply reduce friction in how you work with the model. Our third moment is about connecting workflows across Remsoft applications. So today, in other applications, even if a scenario is optimized and validated, there's still a break when it's time to move it to other workflows in planning. You typically have to extract the result and rebuild it in another system. So here, what we're proposing is that when the scenario is ready, once it has been analyzed and validated, and perhaps here in this case, applied to the map, you can directly move that to create, to support other workflows without a disconnect. So what happened behind the scenes is simple. We sent, in this case, a structured data package on the GIS feature service, for example. So here, we're trying to avoid having to reformat or to manually transfer files. The data now just moves to where it's needed. It's a small step, but it removes some very real friction between planning and other tasks in the operations. So what we've seen so far is the foundation of the new platform. And once that foundation exists, it opens the door to a new generation of planning tools. And what I'm going to show you now are concepts. So you will see, I'm going to present mock-ups, drawings, if you want, and just to share what we're thinking about for the next step, okay? So in terms of supporting structural visibility, earlier I mentioned that I want to make the structure of a model more visible. So this is an example of what it could look like. Here what you have, you're looking at one single constraint. But instead of seeing just syntax, you see how it connects to the rest of the model. You see which indicators that constraint references. You see which resources it applies to. You see what decision it affects. So in other words, you see the relationship between actions and constraints and landscape and resources all in one place. So today, to be able to do that, you would need to open multiple files and mentally restructure how that works. So the goal here is to make that structure immediately visible. Then, once you can see the structure of the model, the next step naturally would be explaining why does a solution behave the way that it does. So instead of going through multiple reports or files that the solver has created manually, I can directly see the main forces that shape the solution. I can see which constraints are actively influencing the outcome. I can see where the model is being limited. At the same time, I can see where there is still flexibility and where the system has more room to move. Now, let's be clear about one thing. In linear programming and optimization, the models will not have one single explanation. Each decisions are the result of many interacting factors across constraints, across time, across space. So this is not about explaining each decision precisely, not even about identifying one exact cause. And even with predictive analytics, that level of explanation would not be really possible. What we are trying to do, however, is that we want to make the main forces visible so that planners can understand what is shaping the solution and reason about it more effectively. So this doesn't change the model, it helps us understanding it. Instead of reverse engineering the results, you can see directly what has shaped the solution. So this could become part of new diagnostic tools that will make optimization results easier to interpret, explain, and trust. For the third moment here, for exploration, what we're thinking about, for example, is more visuals. The example given here is for the supply chain as a whole, or otherwise known as allocation optimizer, and where you can see where harvest and where purchase would occur, where are the origins, how the wood move according to the delivery schedule, and where it is processed. You can move through the system, you can see the different elements, and you can understand how everything connects. Instead of navigating through multiple files and reports, again, you're able to explore the system directly. And that makes it much easier to ask questions, test ideas, and understand how the system behaves. So optimization becomes less of a black box and more of a dialogue with the system. Now, I also have a fourth element, something that's actually very important to me, is that as you have a planning software that is very, very powerful, there is something to me that becomes equally important, how you learn to use it. So over the years, we've seen that the most successful planning teams, they're not just those with the powerful tools, they're those who deeply understand how planning systems behave. So one direction we are working towards is creating a learning initiative around this idea, helping planners understand optimization, model design, and planning systems. Think of it as a Remsoft Academy. So right now it is still early, but the goal is to build a place where planners can learn not just how to make clicks in the software, but learn how to run models. Sorry, not just how to run models, but how to think about models and how to think about modeling. So we're still at the beginning of that initiative, but we believe that supporting learning will be just as important as building excellent software. So far, I've shown you where we believe forest planning optimization is heading, and some of the foundation that we are putting in place to support that future. Of course, innovation is only one part of the story. The other part is transition. Because for many organizations, you have built models, and those models represent years of work. They represent experience, they represent trust. So it would be natural that the next question is, how are we going to get there? And so we want to make sure that we're going to get there in a way that is practical, safe, and valuable for the people who rely on our tools every day. And that's what I want to cover next. So with the models that you have built and refined through the years, we know that they represent tremendous amount of expertise, your company planning reality, they have your scripts and your data automations, and they have deep knowledge of modeling workflow. And we know that that work is extremely valuable. So I want to be clear about one thing, your models are safe. What we are building does not replace your work. We want to build on it by giving you better tools to understand it, to explore it, and to evolve it over time. And so for this transition between the Woodstock Classic and the Woodstock Next Gen, our approach is gradual and practical. Okay? We are very intentional about the pace that we're taking this and how we build it and how it's going to get introduced. We're going to release Woodstock Next Generation progressively, and we're going to do it in a manner, in steps as the features that are in it support your critical business requirements. At one point, you will be able to use Woodstock Next Gen alongside Woodstock Classic, and then over time, as the capabilities will all be there, there's going to be a natural shift, and we will also announce an end of support for Woodstock Optimization Studio. And we will help people transition in there. So we're not looking at a big bang, big switch. We want something that is gradual, and we want to have the space to adopt the new platform at a pace that makes sense. So what this means for you today is that there are a few simple ways that you can engage with this. You can participate in early testing as new capabilities will become available. You can give feedback on your workflows. What works today, what doesn't work, what would you like to see improve, or what's missing? And you can help shape the tools that Planner will be using in the future. Because this is not something we want to build in isolation. It is something that we want to build with the people who are using it every day. And so, behind this work is a very dedicated team of engineers and analysts working together for the next generation of planning optimization tools. I am very honored and thankful for their commitment, their energy, their curiosity, and the care they bring to work every day. This is a team that shows up, takes ownership, and is deeply invested in what we're building at Remsoft. And this is not something we're approaching as a short-term project. It is a long-term commitment, a sustained investment in how planning tools will support you. And you can see the name, but I just want to highlight them. We have Maxwell, Alec, Jonathan, Kevin. We have Christiane, Mike, Jesse, Ulysses, Andrew Cogswell, Ashraf, Everett, Lucas, and Hugo Funikes. And this was me before my midlife crisis. And so we're incredibly excited about where this is going, not just because of the technology, but because of what it will enable. Better tools to support planning, better understanding of the system we manage, and ultimately better decisions. And we're looking to building this together with you.